talk about two case studies on digital advertising and social media marketing, and we'll show, these are two case studies where we have shown that using data science and predictive analytics, one can accomplish business value. So we'll go through these examples. And here's a quick overview of my company, Tiger Analytics, which I started 3 years ago. It's a boutique consulting company in the space of data science and data engineering. We work in a variety of domains, and we have worked with a large number of customers, including some big ones like Cisco, Intel, Walgreens, as well as many startups. And the case studies I'm presenting today are the ones we work with a couple of startup companies, building solutions for them based on advanced analytics and data science. We are headquartered here in the Silicon Valley with additional offices on the East Coast and in India. And we have a booth here. I encourage you to come to our booth to learn more about and meet our team. So coming to the two case studies, one is, they are both related. One is on how to optimize your spend on the display advertising through real-time bidding. So how many of you are familiar with real-time bidding environment? Some. Okay, so what I'll do, I'll give you a quick overview of what real-time bidding environment is, and what kind of data we get there, and how we can optimize the data to do better ad targeting. And the second case study is on using social media data. Again, you get a lot of rich data in social media, variety of data, highly unstructured textual data, but a quite rich amount of information if you mine it properly. And we'll walk through a case study on using social data for customer acquisition for a major credit card company. So real-time bidding, it's a very interesting way the advertising is done there. So suppose you go to a website, say New York Times, and if New York Times has already sold an ad spot, they'll display the ad. But many times what happens, you go to a website in New York Times, and they don't have any ad campaign sold to that ad spot. So in that case, what happens, they'll display the content right away. And you may have noticed sometimes there's a delay in the ad's appearance. You may have noticed that. Maybe a second of delay, half a second of delay. And what happens is, you send your information, at least your IP address. You may send additional information from your cookie tracking, whether you are, what your gender, your demographic information, age, and various information. And then they send you back targeted ads, right? So the way this whole mechanism works is, you as a user, you send the request to New York Times. If they already have a pre-sold ad spot, ad there, they'll show you the ad right away. But often, and that happens more often for smaller websites, not for New York Times, which may not have their own sales team, and they'll send this ad impression to an ad exchange. It's like stock exchange. It becomes publicly available to anyone who's registered on the ad exchange to push the ad advertisement. And there are a number of ad networks who are registered for this ad exchange, and they bid on that ad spot in real time. And whoever wins the ad spot gets to display the ad of his or her choice. So while you're waiting for, when you type NewYorkTimes.com and you're waiting for the content to appear, all this thing takes place. A real-time auction takes place, and one ad network who wins the ad spot gets to display maybe a electronics ad or ad for Toyota or Coke of their choice. And this whole process takes typically half a second or less. And that's the kind of delay you may see in the appearance of ads. And real-time bidding is a significant size of online ad market. Right now, there's $8 billion of ad spend happens through this platform, a real-time bidding platform, which is more than almost double of the ads that Facebook serves. So it's a big market. Now, one good thing here is that you get very rich data. access to rich data as an advertiser, as an ad network. You have access to all the detailed data for every ad impression that comes to ad exchange. And one can do significant amount of data mining, predictive analytics there to get better business value. And we'll show one case study on that. So here, one key problem is, how do you make your ads more relevant, right? You want to have good engagement with the customers for your ad. One metric is how often people click on your ad. That is CTR, click-through rate. And you want to maximize the click-through rate for all the ads that you show. So in this case, what the ad network, every time the ad impression appears, the ad network gets the access to the URL where you are, the page URL, and they have access to all the content on the URL, as well as they have some information about the user. So they have information about two things: the web page that you're viewing and some information about you. If they have detailed cookie tracking, then they would know a lot of information about you, but at least they know your IP address, geo, what browser you're using, operating system, time of the day, some basic details. And the goal is to identify, given an ad campaign, how likely the user is going to click on this ad. And the better if you have high CTR, it leads to lower cost to advertisers and is a good proxy for post-click engagements. We have seen that there is a high correlation for CTR for every follow-up activities. And here is one sample data set. You get huge amounts of data, as I mentioned earlier. The page that you're looking at in the ad, we categorize the page, but based on is it a sports category, maybe some further subcategories there. Does it talk about finance, entertainment? And based on that, you can decide what ad to serve. Similarly, we have a lot of information about the users. So we get, and every day, the ad network gets to see billions of impressions. So you have tons of data. And so what we do, what we see here is also a big data challenge. You have thousands of variables of data and hundreds of millions of data points of impressions. And the data is highly sparse, a lot of missing data. And clicks are rare. Typically you see one click in 3,000 impressions. So the question becomes, how do you build model on this data? So we went through a lot of data cleaning, data processing. And we used one trick that helped a lot. Even if you do significant data processing, if you're building any even basic statistical models, logistic regression or neural network on hundreds of millions of records, it can take huge amount of computing time. It can take weeks of computing time even on fast machines. So one trick that we used is a case sampling, where what happens when you have rare events, where clicks are happening 1 in 3,000 times, rare event analysis, then you can do intelligent sampling, where you keep all the clicks and take a random sample of non-clicks. And the model performs as good as keeping all the data, but the computing time reduces significantly. So generally, when people all know, everyone knows about random sampling. If you do random sampling, the drawback of random sampling is that the model accuracy reduces as you reduce the sample size. But in this case, if you're keeping all the clicks, suppose you have 1 billion impressions and you have 1 million clicks, you keep all 1 million clicks. Of the 999 million non-clicks, you take a random sample, let's say 1% sample. And it turns out that the performance of the model accuracy would be as good as keeping all 1 billion impressions, but the computing time will slow down, will be faster by 100-fold or more. So once we do that, here is result for one sample campaign. We saw that pretty good lift chart. For the first 20% impressions, we were getting 180% better CTR than a random sample. And this is just one campaign. We built this model for a variety of campaigns. Every campaign we had to build the model separately. We got on an average 30% to 50% lift in the first 20% of impressions. So what it means that you are spending only 20% of the cost, but getting as much as 50% or 56% of the value of the number of clicks. The models also gave meaningful insights where people are clicking, which geo, which websites, which domains you're getting clicks from, and this was helpful for designing the campaigns and also in the sales process for when you're selling the campaigns for the salesperson. So that's the first case study. Let me move to the second case study, and then we can take questions at the end for both of them. In the second case study, we were leveraging social data, and as you know, the social data it comes from a variety of platforms like Facebook, Twitter is a very popular place where everything public data. So what we were looking at, does the social data have right signals to do better ad targeting? Can you improve your CTR further by leveraging social data? So we built a platform. Here we are leveraging all kinds of social data coming from Facebook, Twitter, blogs, forums, as well as available at enterprise level like data set. We process all this data, crawl all this data, build into our own database, and then do machine learning on top of that to derive various topics, interests, sentiments, and so on, and that would be used for ad targeting. So overall, we have this infrastructure where you start with unstructured data that you see in the web, crawl the data, and that becomes semi-structured JSON objects, and then we apply machine learning techniques to convert the data into a structured data, because unstructured data cannot be used for any kind of statistical modeling. So we apply machine learning techniques to convert that into structured tables. And the structured tables can contain information about the users, what interests the users have, or information about the brands, how often the brand is being mentioned. You can have trend information if something is trending up or down. And so here's one example. So on this tweet, you see Julia, she talks about go to Alaska to watch Northern Lights. And this tweet, we mine it and identify that it talks about travel. So she likely has interest in travel. We raise the travel score, and then a travel-related ad to be targeted to her. So similarly, we mine all the Twitter messages and convert that into a set of interest segments. So right now we have some 500 interest segments, and these include people who are interested in fitness enthusiasts, or restaurant goers, or people interested in hiking, travel, electronics, and so on. So we mine all the messages on Twitter and Facebook and convert that into interest segments. Then we take all these interest segments, some 500 of them, combine that with gender and age groups. It converts into some 3,000 micro segments, and we use those micro segments for ad targeting. So we do given an ad budget. Let's say you have ad budget for $100,000, then we identify which micro segments are performing well and start shifting our budget to the micro segment where we have better performance. So we ran a very large campaign. It was a year-long campaign, spending more than $10 million on this campaign. And the goal was to have final customer acquisition, final credit card sign-up for a major credit card company, major bank. And in this case, the data was very, very sparse. You start with 1 million impressions. Typically, you get 300 clicks. Of those 300 clicks, you get 1% applications, 3 applications, and that leads to one final approved credit card. You get very sparse data. And we were optimizing the whole funnel use the interest segments that we created from social data and see if we can do better targeting. Okay? So what we did, we take the budget, daily budget, divide that into a small budget for each micro segment, throw some small budget on each micro segment, and see some early indications of are we getting clicks, applications and conversions, early indicators, and wherever we are seeing better signals, we start shifting more budget toward those micro segments algorithmically. And also these ad spots are being bought through real-time auction, so we start also shifting the bid prices higher to micro segment where we have better performance. So of the 3,000 micro segments we created, you start increasing budget as well as the bid price to micro segment where you see early indications of performance. So we do that algorithmically, and this system that we built is being every 15 minutes automatically it refines the performance of micro segments and shifts the budget and bid prices automatically. And so once we ran this campaign for several months, we saw consistent increase in the click-through rate, as much as 50% increase in click-through rate, as well as decrease in cost per acquisition by as much as 25%. So it validated that mining those interest segments from social data was able to provide us additional data to do better targeting of ads for this particular campaign. And here these were mainly business cards. So we're looking for customers who are interested in travel, who spend a lot of money on luxury goods, and those segments were more effective in getting better CTR and better CPA. So overall, in summary, the online and social advertising, they are fast-growing areas with plenty of data and a large number of interesting problems. One can mine this data. You end up getting terabytes of data here in these platforms, and one can mine this data and draw good business value by applying concepts of data science and predictive analytics. And we have shown in these two case studies have shown significant improvement in CTR, which leads to better targeted ads, as well as much as 25% reduction in cost of buying media. We have developed these solutions for a couple of startup companies. They are in the production environment. They are using the solution to serve billions of ads for leading companies in Fortune 500 companies. So that's all. I can take a few questions now, and if you have any question later, then you can reach me at this email address.
Anybody have any questions now?
I have a question on the case study one. So you applied looks like you applied the lift charts to find first 60% of your customers who are highly profitable CTR.
Yeah.
So how do you apply this real time? Did you apply any weighting schemes? Like how do the customer ad exchange know which ad has more weightage compared to the other ad, or which segment has the other?
Yeah. So what we do here, the models were built not in real time. So the models were built because it's a very extensive job to build the models. The models were refreshed every day as a batch run at night. And once the model is built, for every campaign, the customer they are running hundreds of campaigns. For every single campaign, we build a separate model, and the model produces an equation which is used for scoring in real time. So in real time, when a new impression comes, right? When a new impression comes in real time, say this impression, then the formula that we updated in the batch run overnight, that is used to compute the score of likely probability of this ad being clicked, right? As well as any potential post-click engagement. And that is used for bidding, whether we should bid on the ad or not, and how much we should bid. So if you see that the score is very high, the probability is very high here, then you're going to bid high for that particular impression. If the probability is low, then you may decide either not to bid or bid very low. And that what was done in real time. And it says typically they get only 50 to 100 milliseconds to make a decision and do all these computations. I can't.
Can you expand more on the technologies you used for the real-time scoring?
The real-time scoring, it was used. We used a enterprise solution from Zementis, and we like my team was not as much involved in the real-time implementation part of it, but we were building the data science part of it. We collaborated with this startup company which already had the scoring system from Zementis, and what we were building is the data science part. Every night batch run, how to have a model refreshed and come up with a formula that could be used for scoring.
Well, thank you. I believe we're out of time, but let's give Dr. Kumar a hand.